Hello everyone, welcome to AcadUCATION. Let us start with our topic distance, speed and time. Soon as we hear the term speed, what is it that comes to our mind? It's just that how fast a body is moving, right? But this is not enough to solve questions. For questions we need formulas, so let us see the formula for speed. Speed is basically distance divided by time. The distance an object covers per unit time is its speed. For example, if I say speed of an object is 60 kilometers per hour. So what we mean is the object moves 60 kilometers in 1 hour. So this is the basic formula to find speed. There are two more variations to this formula. So if we interchange speed and time, we would get time is equals to distance upon speed. Similarly, if we multiply speed by time, we would get our distance. So now let us look at a very basic question on this topic. So the question is as follows. A train is traveling at the rate of 45 kilometers an hour. How much time will it take to cover 30 kilometers? So we are given that speed of the train is 45 kilometers per hour. Now what this means is the train covers 45 kilometers in 1 hour. We are required to find the time it will take to cover 30 kilometers. So can I say that it covers 15 kilometers in 20 minutes? If I divide my hour into 3 sections of 20 minutes each, 3 parts of 20 minutes each. So my speed would be 15 kilometers in 20 minutes. Again 15 kilometers in 20 minutes and the third 15 kilometers in 20 minutes. When we combine all three, we would get 45 kilometers in 60 minutes. That is 1 hour. So if it travels 15 kilometers in 20 minutes, it would take 40 minutes to cover 30 kilometers. So let us look at another question. Try this question for a minute and then we'll discuss how to solve this kind of question. Now the question says, a boy runs 20 kilometers in 2.5 hours. How long will it take to run 32 kilometers at double the previous speed? So what would be our speed? That is distance upon time. So distance is 20 kilometers and time it is taking is 2.5 hours. So this is our initial speed that I denoted by SI. Now we are told to double the speed. So what we get is initial speed is 20 upon 2.5, that is 8.5 kilometers. If we double this speed, our speed would be 16 kilometers an hour. Now we have to travel 32 kilometers at this speed. So how much time will it take? It would take 32 divided by 16 kilometers per hour. Distance upon speed is our time, right? We saw some time back. So time would be 2 hours. So this is our answer. Many a times we would be required to convert kilometers per hour into meters per second or vice versa. So let us see how to convert kilometers per hour into meters per second. So in 1 kilometer, what we have is 1000 meters and we divide it by hours. And in 1 hour, how many seconds do we have? We have 60 minutes in an hour. And in each minute, we have 60 seconds. So 60 into 60. These are the number of seconds that we have in 1 hour. And these are the number of meters that we have in 1 kilometer. So this we have converted basically in meters per second. If you cancel these zeros out, we get 10 upon 36. So we would get 5 upon 18. You cancel it by 2, you get 5 and here you get 18. So basically you need to multiply kilometer per hour by 5 by 18 to convert it into meters per second. So if we see here, kilometer per hour is 5 by 18 meters per second. Let us have a question. Just try this. 72 kilometers per hour. So you multiply it by 5 by 18. This gets cancelled out by 4. You get 20 meters per second. Now let us see the reverse process of it. That is conversion of meters per second into kilometers per hour. So if I ask you to convert 20 meters per second into kilometers per hour, what we need to do is, earlier we used to multiply it by 5 by 18. So now we'll multiply it by 18 by 5. What we get? This gets cancelled out by 4. and we get 72 kilometers an hour, right? Let us look at the concept of average speed now. Now, average speed differs from normal average. How? Like if I tell you a object moves from A to B at a speed of 40 kilometers per hour. An object moves from A to B at 40 an hour and it returns at the speed of 60 kilometers an hour. And I ask you to find the average speed of entire journey. So you cannot just add 40 and 60 and divide it by 2 to find out the average speed. So you can't just say that it is 50 kilometers an hour. Why? Because speed is a derived unit. It is dependent upon distance. It also depends upon time. So this average can be used for fundamental units. If I tell you that you have to find the average of 40 and 60, which are just numbers, then obviously the average would be 50. But in this case, when you are required to find the average speed, you can't just add these numbers, right? So whenever you have a derived quantity, you will have to use the formula, that is total distance upon total time, right? Because formula for speed is distance upon time. So first you will have to find the total distance of the journey and then divide it by total time required for that journey. So let us have a look at a question which is based on average speed. So I've taken a similar question. A person goes from place X to Y at a speed of 40 kilometers an hour and returns back at 60 kilometers an hour. Find the average speed of the journey. So what is the formula for average speed? Total distance upon total time. Let us assume that from X to Y the distance be d kilometers. So what would be our total distance? So d kilometers for forward journey and d kilometers for return journey. Our total distance becomes 2d. So now if total distance is 2d, we have our numerator here. Now we are required to find our denominator, that is total time. So earlier we saw that time is equals to distance upon speed. So for forward journey, our distance is d and speed is 40 kilometers an hour. So this is our time required for forward journey. Similarly, time required for our return journey would be d by 60, because for returning we have the distance as d and we return at 60 kilometers an hour. Now total time would be d by 40 plus d by 60. D by 40 was our time required for the forward journey and d by 60 is time required for return journey. So total time required would be d by 40 plus d by 60. Putting this total time in our formula, so we had our total distance as 2d and total time as d by 40 plus d by 60. So what we'll get is something like this, 2d upon d by 40 plus d by 60. You take the LCM here, you will get 2d upon 2d plus 3d by 120. D gets cancelled out. What we get our average speed as 48 kilometers an hour. So this is the way how to find average speed, right? Now the question that we just solved can also be solved by direct formula. So let's take an example, like when we travel from one place to another and we return back. So our distance is equal, or if we have another situation where we travel half a distance with some speed s1 and another half a distance at speed s2. So now the distance is same throughout, from x to y and from y to z. We have our distance as same and they are traveling at s1 and s2. So we can directly use our formula to find average speed. So average speed can be given as 2s1 s2 upon s1 plus s2. Now if we use this concept for our previous question, what would we get is 2 multiplied by 40 into 60 upon 40 plus 60. So it would have been easy to solve this way, right? Because from here we directly get our answer as 48. Let us see another question which is asked on this topic. So try this question for a minute and then we will discuss how to solve this. So what the question says is, A train travels a distance of 20 kilometers at a speed of 20 km per hour, and after that it travels 40 kilometers in 2 hours. So we are given with two different things. It is traveling from A to B, but in the whole journey it is traveling in two parts. Like from A to C, it went 20 kilometers at 20 kilometers an hour, and from C to B, it went 40 kilometers in 2 hours. So we are not given with the speed from C to B, but distance and time. And from A to C, we are given with distance and speed. And we are asked, or we are required to find the average speed of entire journey. So to find that, what we'll do is, we'll first take out our total distance. So what would be the total distance? From this point A to from point C, the distance is 20 kilometers, and from point C to point B, the distance was 40. So our total distance becomes 60 kilometers. And our total time, what would be our total time? So if it travels from A to C at 20 kilometers an hour, so it is basically traveling 20 kilometers at the speed of 20 kilometers an hour. So it would take 1 hour, and it has taken 2 hours to travel another 40 kilometers. It is directly given. So total time is 3 hours. So what you are required to do is, total distance is 60 and total time is 20 by 20 plus 3. Sorry, this should be plus 2. So our total time becomes 60 divided by 3. So we get 20 kilometers per hour. Let us take a look at another problem. Try this for a minute and then we'll discuss. So it says a person travels from one place to another at 30 kilometers an hour and returns at 120 kilometers an hour. If the total time taken is 5 hours, then find the distance. So we are given with two speeds, one is 30 and one is 120. And we are given with the total time as 5 hours. So we know that distance upon speed is what? Time. So our onward and return journey speed is given 30 and 20. So we can say that it went d distance at 30. So the time required t1 would be d by 30, and it returned back at 120 kilometers an hour. So time t2, that would be distance d again and upon 120. And this should be what? The total time. And this should be equated to 5. So this should be our answer. So what it is, d upon s1 plus d upon s2. This is the total time taken for the journey. So d upon 30 plus d upon 120 is 5. You take the LCM. LCM would be 120. So we get 4d plus d upon 120 is equals to 5. So what we get as d? We get 120 kilometers. Let us take another kind of question from this topic. So a man travels from his home to office at 40 kilometers an hour and reaches 10 minutes late. So he might be traveling at some speed s, but when he travels at 40, he reaches at time t plus 10. So he is basically 10 minutes late. If he travels at 60 kilometers per hour, so now what he has done is he has increased his speed by 20 kilometers an hour. So obviously if speed is increased, time required to reach office would be bit less. So he reaches 10 minutes early. So now he reaches at within t minus 10 minutes or t minus 10 hours, whatever it would be. Right? So let us take that he reaches at 13 hours and 40 minutes, that is 140, while traveling at 40 kilometers an hour. So what I am assuming is that when he travels at his usual speed, he reaches at 30 hours. So when he is traveling at 40 kilometers per hour, so he is 10 minutes late, and thus he reaches at 1340. And he would reach at 1320 when he is traveling at 60 kilometers an hour. So he reaches 10 minutes early. Now, what is the difference in the time taken at two different speeds? So difference in time taken is 20 minutes. That is, when he has increased his speed from 40 to 60, time is reduced by 20 minutes, right? So can we say that T1, that is when he was traveling at 40 kilometers an hour, minus T2 when he is traveling at 60 kilometers per hour. So this should be equal to what? 20 minutes, right? So let us see how can we write that. So d upon 40 is the time required when he is traveling at 40 kilometers per hour. So we have taken the distance as d. Now when he travels the same distance d at 60 kilometers an hour, he would take d upon 60 amount of time. And which time would be more? Obviously d by 40 is more, right? 20 minutes. So we have equated it to 20 upon 60. So this is our T1, this is our T2, and this is the difference between the two times. Now why we have divided it by 60? Because these times are in hours. We are given with our speeds in kilometer per hour. So the RHS quantity should be written in hours. So because this should be in hours, so we have converted our minutes to hours. So if we solve this, we'll take our LCM to be 120. So we get 3D minus D minus 2D, and this should be equal to 1 by 3. When we solve this equation, what we get is D equals to 40 kilometers an hour. Sorry, 40 kilometers. So this is the total distance that the person travels from his home to office.